Hello, algebra students. Mr. Lawrence here, and we're going to do some more factoring and solving quadratics. This is the video for Wednesday, May 6th. All right, one thing I want to point out to you, I've said it many, many times, but it just doesn't register. You always want to try to factor out a common factor first. A lot of times we call this a GCF. It doesn't necessarily have to be the greatest common factor. Sometimes it could be a negative in certain situations, but try to pull out a common factor. Won't always have one, but look for it first thing you do. All right, let's check out number one here. Now, I see it's a trinomial, okay? I see a is not 1. I know some different techniques to do this. I'm looking for a common factor. I don't see one between 81x squared, 28x, and 25. So now I'm going to check to see if this is possibly a perfect square trinomial. If it's not, I'm going to have to use that method you saw in the video 2 nights ago. So first of all, let me take the square root of this. Is it a perfect square? It sure is. It would be 9x. Now I'm going to take the square root of 25, which is 5. If I multiply them together, it's going to be 45x. If I double that, I get 90x. Notice the 90x does not match the 28. It's actually a mistake on my part. I wanted it to match. As it was written, you could not factor that one, okay? What I need here is a 90x, because I multiply these two together, get 45x, double it, it matches. This is a perfect square trinomial. Here's how simple this is to factor. I'm going to have a 9x and a 5, and then a 9x and a 5. Now remember, when C is positive, B's sign shows up twice. That's the thing I call the Wendy's double stack. When C is positive, it shows up twice, just like that. All right, so we're going to do 9x minus 5 equals 0. I'm solving this quantity for x. So 9x is going to equal 5, divide by 9. X is going to equal 5/9. I don't have to solve this one because it's identical. So my solution for x, y is 0, x will be 5/9. Okay? In other words, the parabola will cross the x-axis one time at this point. Now you only have to report this answer, but I'm just trying to give you a context. Okay, this is a quadratic, so therefore it makes a parabola. All right, number 2. It looks like it could be a perfect square, a difference of perfect squares situation. However, 50 is not a perfect square, neither is 18. But I am noticing a GCF in here. I notice a 2x. I'm going to factor out a 2x. When I do, I'll be left with 25x squared, which is a perfect square, minus 9, which is a perfect square. This thing inside is a difference of perfect squares pattern. So the square root of that would be 5x. Square root of that is 3. It's going to factor like this. I have a 2x out front. Can't lose that 2x. Then I'm going to get two quantities. I'm going to get a 5x and a 3, a 5x and a 3. Now some of you get screwed up on the signs. Well, take a look at C. C is negative. That means I need one of each sign every single time. Now to solve this one, I'm actually going to have 3 solutions because I see 3 quantities. Do you see the 3 quantities? The first 2 are obvious. There's a quantity here. There's a quantity here. There's also a quantity here. I didn't put it in parentheses because they're not necessary, but it behaves just like a quantity. So the first thing I'm going to do is 2x equals 0. Then I'm going to have 5x plus 3 equals 0. And then I'm going to solve 5x minus 3 equals 0. So if I divide by 2, x is going to equal 0. Subtract 3, get 5x equals negative 3. Divide by 5, and x is going to equal negative 3/5. Here I'm going to add 3. 5x is going to equal 3, divide by 5, divide by 5. X is going to equal positive 3/5, right? So this is actually not a parabola. it's going to kind of do something like this, and it's going to cross the x-axis in 3 places. What are those 3 places? Well, they are at negative 3/5, 0, and positive 3/5. And there you go. There's the 3 solutions. All right, number 3. I don't see perfect squares, but I do see a GCF. I see it too. I'm going to pull the 2 out. I'll get x squared minus 2x minus 63. Now, this is not a perfect square trinomial, so I'm going to list the factors of 63. So 1 and 63, 2 doesn't go in, 3 and 21, 4 doesn't go in, 5 doesn't go in, 6 will not go in, 7 will go in 9 times. All right, 8 will not go in. I need 2 factors of 63. That's subtract. How do I know it's subtract? Because c is negative. That's subtract to get negative 2 as an answer. Well, hey, how about 7 minus 9? A positive 7 and a negative 9. Now, once you know that, this factors really simply. 2, you're going to have 2 quantities. The x is going to break down like that, and then you need a positive 7 and a negative 9. Positive 7, negative 9, that will equal 0. Now, in this one, I only have to solve 2 quantities because only 2 of my quantities have variables. I don't need to solve this one because 2 can never equal 0. So I'll do x plus 7 equals 0, and x minus 9 equals 0. And when I solve, I'll get negative 7 and positive 9. And so my solution set would be negative 7, 9. So this would be a parabola. It will cross the x-axis twice at negative 7, 0, and at positive 9, 0. All right, number 4. Number 4, let's see here. Okay, I don't see a GCF in it. I don't see a, oh, I do see a GCF. See that x? I'm going to pull an x out. I'm going to have a 15x squared plus a 7x minus 2, and that'll equal 0. Now, inside there I have a trinomial, but it's not a perfect square trinomial. A is not 1, so I'm going to have to list a couple sets of factors. I'll have to list the factors of 15, which there aren't that many, and the factors of 2. Now, this is where I multiply one of the factors of 15 with one of the factors of 2, and then I multiply their partners together, and in this case, because c is negative, I will subtract. What number do I want to get when I subtract? Positive 7. So what about 5 times 2, which would be 10, and 3 times 1, which is 3, and 10 minus 3 is positive 7. So I'm ready to factor and have that x. Don't throw your GCF away. I'm going to have 2 quantities. Okay, I got the 3x and the 5x, and right, remember those little loopy guys? The 5 got multiplied by the 2. The 10 was positive, so I need a positive 2. The 3 got multiplied by the 1. It was a negative 3, so I need a negative 1. So now I will have 3 solutions. I'll have to solve x equals 0. Well, that's a hard one. And there's my first answer. I'll have to solve 3x plus 2 equal to 0 and 5x minus 1 equal to 0. If I do that, I will get a negative 2/3 and a positive 1/5. And there you go. All right, that's it for the video. We're going to get some practice in class Thursday. Mr. Laurence signing off. Have a good night, everybody.